Hello and welcome to this morning's learning lecture for higher students at St Thomas Aquinas. So, first of all, I'm going to go through very quickly, just for the first time, how these learning lectures are going to look for you, because you might not have seen them before. So you should arrive from a lineup. You might arrive a little bit before this, but I've allowed 5 minutes to get there from the lineup. So arrive from the lineup at 8:35, and then straight away you're going to do a key knowledge test. Now, these are going to be topics that you should know how to do, okay? I am going to go through them and mark them, but it's just 5 minutes just to keep you refreshed and just to keep you topped up with some of the key knowledge for higher mathematics. Once we've done that, we're actually going to look at some GCSE questions that I'm going to do. So I'm going to do usually 3 or 4 GCSE questions, and then and then you've got an opportunity to have a go at some yourself, and then we'll finish off with a morning prayer, and then we leave for lesson 1. Okay, so in front of you, you've got your key knowledge test printed out. Can you have a little go at that now? So there it is. You've got 5 minutes to do this. So you've got 5 minutes to do this. I'll put 5 minutes on the timer, and off you go. Okay, so let's have a look at these together then. So I wrote some of these out. We shouldn't take too long. As I said, these are key knowledge questions. So these are things that you'll need to progress to those harder questions. So let's have a look at this first one. So the first one says, write this number in standard form. So what we need to do is we need to jump this decimal place so it's between 1 and 10. So it should be 1, 2, 3. And to get to between 1 and 10, it would be there. So it's going to be 3.05 times 10. Now this is a small number, it's a decimal. I'm going right with my jumps, so it's going to be to the -4 with that one. 3.05 to the -4. Next one says the upper and lower bounds for 3 significant figures. Well, to find the upper and lower bounds, we halve our accuracy, add and subtract it. So our accuracy for here is this part here, my third significant figure. So where does my third significant figure appear? Well, it's actually here, isn't it? Which is going to be my my second decimal place. So you've got to use the unit value for that. So it's going to be 0.01. Just take note, if you haven't got these right, get these down now. The reason for that is the next time you do this, it's going to be exactly the same questions, just with different numbers. Okay. So third significant figure. So I halve the accuracy, add and subtract. So half my accuracy of this is going to be equal to 0.005. And then I'm going to add and subtract this to my number. Okay? So I add and subtract it to my number. So if I subtract this from the number, it's going to be 2.155. And this is my lower bound. And my upper bound, if I add 0.05, is going to be 2. Make sure you can see that, 2.165. So I've halved my accuracy, which in this case was my third significant figure, which was here, add and subtract it. So I'm minusing 0.05 and I'm adding 0.05. Okay, the next one for my area here. So it's asking us to find out the base of this, which is Z. Okay, so if I want to work out the base, you first got to know the formula for the area of a triangle. I'll make this, I'll rub this part out so you can see it. I'll do it on this side. So this is equal to 4. Now, you've got to remember that the area of a triangle, base times height divided by 2. So I'm going to write that down. Area is equal to base times height divided by 2 there. And then I'm going to sub in the things I know. So I know that my area is equal to 12. My base is Z, so that's the thing I don't know, times by my height, which is 4, divided by 2. And I'm going to work backwards and solve that. So if I times by 2, times by 2, 2 times by 2, that will cancel. 12 times by 2 is 24, which is equal to 4 times by Z, which is 4Z. And then divide by 4, divide by 4. So Z is going to be equal to 24 divided by 4, which is 6 centimetres. So Z is equal to 6 centimetres. I'd probably check that. Does it make sense? 4 times 6 is equal to 24. Divided by 2, 12. Yes, my area is right. Key thing here, remember that with triangles we divide by 2. Okay? This one here, just a little substitution question. So we're going to substitute in now. Remember, substitute means replace. So it's going to be 3 squared plus 6 over 3, because Z is equal to 3. So 3 squared is 9. 6 divided by 3 is 2. 9 plus 2 is equal to 11. There's your answer. Brilliant. Divide this in the ratio of 72. So it's all about the word parts in this one. So how many parts are in this? Well, if I know that this represents all of this. So it represents all of this 7 to 2. So 63 is equal to 9 parts, which is all of this. And then I'm dividing each of these sides to find out one part. So 63 divided by 9 is equal to, let's do it, 9, 18, 27. I'm getting it wrong now. 9, 18, 27, 36, 45, 54, 63. So it's going to be 7 is equal to that. 7 is equal to 1 part. Brilliant. But I don't want 1 part. I want 2 parts and 7 parts. So to find 7 parts, I times by 7. To find 2 parts, I times by 2. So 7 times by 2, which is going to be equal to 49, is equal to 7 parts. And to find 2 parts, I times this by 2. So it's going to be 14, which is equal to 2 parts, like so. So the ratio is 49 to 14. Brilliant. The next one here says make Z the subject. So here I've got C is equal to minus 4Z to the minus 4Z squared. So I'm going to divide both sides here first by this one here. So divide by minus 4, divide by minus 4. So I end up with negative C over 4 is equal to Z squared. And then to get rid of this Z squared, I'm going to square root both sides, So I end up with the square root of minus C over 4 is equal to Z. Now, I've run out of time there, so I'm going to just pop the answers up for that. So here are your answers to mark the rest of them. So the last one there was 8.6. And your upper bounds for this one was at, I believe, I'm just going to check that, 162.5 for that one. Brilliant. Okay, so today we're looking at percentages. Okay, so what we'll do now, turn your book over now. You'll notice there's 3 questions here on percentages. I've made it quite easy today just to get us into the swing of things. Okay, now the thing is with these types of questions is this is not a normal percentage question. This is a reverse percentage question. So here we need to be working backwards. Okay, so there's 2 things we need to think about. What is the normal price of our, in this case, saddle for the horse, and what is our new price for the saddle of the horse? Okay, so straight away it says that in a sale the normal prices are reduced by 20%. So my normal price is worth 100%. We know that. Okay, and your new price is worth, well, it's been reduced by 20%, so this is going to be worth 80%. There, like so. Okay, your new price, you could call it the sale price as well, new or sale price. Okay, so now what we've got to do is we've got to use what we understand here to find out what my normal price is, because it's not asking for the sale price here, it's asking for your normal price, and it's all about your starting point. And my starting point here is 100% represented by 220, or is 80% represented by 280? Well, actually, when I look at this, I can see that the 220 is the sale price. The sale price of the saddle was £220, so which is represented by this 80%. So my starting point here would be 80% is equal to £220. So copy this down. You should be getting this down on your sheet, okay? Copy this down on your sheet, and you're going to have an opportunity to have a go at some of these yourself. Okay, so here, my sale price, 80% is worth 220, but now I need to find out what 100% is. Now I'm going to say this is non-calculator, so in which case if I've got no calculator with this, you could, if you wanted to, divide by the multiplier here, which would be 0.8. But instead of doing that, I'm going to do non-calculator methods. So to get back up to 100, I'm going to first find out what 20% is. And I find out what 20% is here by dividing by 8 and dividing by 8. Oops, sorry. Let's find out 10%. We'll do 10% anyway. So if I divide this by 8, I get 10% here. And if I divide this by 8 here, let's do that on the side. Make sure you can see that. So 8 into 2 doesn't go. 8 into 22 goes 8, 16, so it goes in twice. Remainder 6. So 8. So to find out what 20% is, I'm going to divide both of these sides by 4, because 80 divided by 4 is 20%. So 80 divided by 4, I know it's 20%. 220 divided by 4, that one's a little bit trickier. I'll do that just underneath here. So 220 divided by 4. 4 into 2 doesn't go. Okay, fine. 4 into 22 goes 4, 8, 12, 16, 20. So 5 carry the 2. And 4 into 20 goes 4 times. So this is equal to 54. Brilliant. So then I know what 20% is. Remember, I'm trying to find out what my original or my normal value is. And in which case, we're looking for this 100%. So here I'm going to be timesing by 5 and timesing by 5, because 20% times by 5 is 100%. So if I times this by 5, I need to times the right hand side by 5. So I'm doing 54 times by 5. 4 times by 5, 0, carry the 2. 5 times by 5 is equal to 25, and the 2 is equal to 27. So the answer is 270. Brilliant. So just a little note on that one. The key part to this, and the thing of understanding, it probably might be worth writing this down actually. When you have got a percentage question, you're looking for, are they asking for the new price, in which case you just use the normal methods, or are they looking for the original price, or the starting price, or the price before? If it's past tense, then we've got to use this technique. And I'd always suggest starting off with this, writing out what your normal percentage is, and then writing out what your new percentage is. Okay? Let's have a look at the next question then. So the price of all rail season tickets is increased by 4%. Okay? It's increased by 4%. The price of the rail season ticket from Cambridge from London to Cambridge is increased by £121.60. Work out the price before this increase. So we know here, now this one's a little bit trickier again. Okay, so we know that our normal percentage, or original percentage, I should probably put, my original percentage is equal to 100%. We then know that my new percentage is equal to, if it's an increase of 4%, it's going to be 104%. Now the thing that makes this one trickier is it says the price of the rail season ticket from Cambridge to London is increased by 121.60p. So actually what's happened here is it's telling us what the increase is, and the increase here is 4%. Okay, that's really tricky, that. So it's telling us our starting point here is that we know the increase. It's been increased by £21.60. So I know my starting point is that 4% is equal to £121.60p. So that's my starting point. It's telling me that the price is increased by 4%. So this £121.60 represents my 4%. So with this, remember, it's asking me for the price before that increase. So it's asking for the original amount, which is this 100%. Now it's up to you how you do this. You might want to divide this by 4, find 1%, and then times it by 100. You could times it by, well, how many times does 4 go into 20? 4 goes in, sorry, how many times does 4 go into 100? Well, 4 goes into 125 times. So you could just times this by 25. Let's do that. Okay, so if I times this by 25, I get 100%. If I times this by 25, £121.60 times by 25, I get 3,040. Okay, so this one, the reason this one is trickier is because they've given us the increase. They said it's increased by 4%, and that increase is £121.60. Okay, let's have a look at one more, and then I'll give you an opportunity to have a go at your sum yourself. So do make sure you're getting this down on that paper, okay? This will come up in the exam, all right? So Anne buys a dress in the sale. The normal price of the dress is reduced by 20%. The normal price is equal to £36.80p. Work out the sale price of the dress. So I've done this one a little bit trickier. Well, this one is actually a little bit easier, okay? Because actually what we're looking at here is it's telling us what the normal price is. So my original percentage is always 100%. We know that. Okay? Here what's happening is it's been reduced. So the new amount, or the sale price, is equal to this reduced by 20%. So 100% take away 20% is 80%. And it tells us the normal price, so this here, my 100%, is £36.80. So it says work out the sale price. So I'm not working backwards this time. I'm trying to find out what 80% is. So my starting point would be 100% is equal to £36.80. Now you might be used to this one. I think the best way to do this is to find 10% first, so divided by 10. So divided by 10, divided by 10. This divided by 10 is obviously 10%. This divided by 10 is going to be £3.68. And then because I want 80 here, I times by 8, times by 8. So 10 times by 8 is 80. And £3.68 times by 8 is equal to £29.44. So that's the new price of this. So there's 3 different types of percentage question there. One where you're trying to find the sale price. So one way you're trying to find the original amount, in which case you start with the sale price. One where they've told you what the increase is, so in which case you start with the increase. And here you start with the original and you're trying to find out the sale price. So there's 3 questions that look really similar, but actually they're quite different. So turn your sheet over now. Have a go at the 5 questions you've got there. Okay. Have a go at those, sorry, not 5 questions. Have a go at the 3 questions you've got there. Okay. You've got 5 minutes to have a go at those. So have a go at those now. They do follow the same order, but make sure you understand them, okay? So 5 minutes, off you go. Okay, so let's go through those answers then. So mark these in green. So here we have our starting point, because actually it's telling us that the sale price is £102. So my starting point is that 102 is equal to 85. They found 1% and then times that by 100 to get the original price, or the normal price, is 120. So the key part of that is that your starting point here is the sale percentage, which is 85%. In this next one, here we've got Will's salary is increased by 4%. So actually, we know his salary is 24,000. It's increased by 4%. So my starting point with that is equal to 100. Find 4%, add it on. They've used a multiplier here, which I haven't talked about today. We could use the multiplier, which is basically just writing. I'll show you very quickly. Multiplier, we know that our original percentage was equal to 100%. Our new percentage, or new amount, original percentage, new percentage, is going to be an increase, which is 104%. So you can, if you want, write this as a multiplier, which is 1.04, and then just multiply by that. So a multiplier is writing this percentage as a decimal. Okay. So let's have a look at this next one. Here we've got this one here. So calculate the normal price of the car. So again, working backwards with that one, our starting point is that the car is, we knew the sale price of the car, which was 80%. And then he's worked 1% and then found 100%. You could have, with that one, found 20% if you wanted to, then times by 5. With this one here, it's a little bit trickier. Not too much trickier, to be honest. So here, the starting point is that the percentage increase. So 140% is equal to 6,000. Then find 1%, then go further. So we know that he's wrong in this one, because actually we've got a strange number here. And if it wasn't wrong, then he would have a whole number here. So it's just taking things a little bit further. So do you understand that for people, it needs to be a whole number? Okay, so thank you for watching this learning lecture. Let's skip back to me. So thank you for watching this learning lecture. Quite a straightforward one today. We've done it in just about the right amount of time. So thank you for watching this, and have a lovely day.